Okay, so ladies and gentlemen, good day all. You are welcome to my YouTube channel. Today we are going to look at the concept of isomerism in organic chemistry. And you can clearly see that this PowerPoint is made by Shibam Sharma. So I'm going to make use of it and make this class. So now I'm starting with the tables of content. That is what we are going to look at. The first thing we are going to look at the introduction, that is definition of isomerism. Number two, types of isomerism. And then number three, in details, that is all types of isomerism will be explained. And then the end points of the presentation. So now what is isomerism? Isomerism is a phenomenon in which more than one compound have the same chemical formula, but different structural or different chemical structures. It means that in isomerism, a compound that have the same molecular formula, but different structural formula. It's a compound that if you see them, you see that they have the same number of carbon, the same number of hydrogen, the same number of oxygen, and any other element. They are the same thing. Their numbers are the same, but in terms of the chemical structure, in terms of the arrangement, they are differ. So this is what you call isomerism. So when a compound have the same molecular formula but different structural formula is what you call isomerism. You see that they have, like, for example, let me just give examples of this isomerism. You can have a situation where you can have a compound like this with, you can have a compound like this, let's say C4H10. So you can see clearly here the number of carbon are 4 and the number of hydrogen are 10. But in terms of the arrangement, you can have something like this. You can have something like this. Here is hydrogen, and here is also 3 hydrogen atoms. So here, if you can clearly see, you see that the number of carbon are 4. You have 1 carbon here, you have 2, you have 3, and 4. So the number of carbon are 4, and the number of hydrogen are 10. So, but the name of this compound is, if you are naming it, it's going to be 2-methyl propane. 2-methyl propane. But so that is the first structure. And then the second structure, you can have something like this. Here we have 3. Here we have 3. 1 hydrogen here, another hydrogen here, another hydrogen here, another hydrogen here. So here you can see that we have 3 hydrogen, we have 2 hydrogen making 5, we have 6, 7, 8, 9, 10. And here is also 10. So if you can look at it here, this one is normal, N-butane is normal butane because there is no any branch. So this is normal butane and this is 2-methyl propane. So in terms of the number of carbon are 4, in terms of the number of hydrogen are 10. So they have the same number of carbon, the same number of hydrogen atoms, but the arrangement of the atoms are differ. So it means that they have different structure. So isomerism are compounds that have this same molecular formula, the same formula like in this case, but they have different arrangement. They have different arrangement. And this is what you call isomerism. This is what you call isomerism. So chemical compounds that have identical chemical formula but differ in properties and the arrangement of atoms in the molecule are called isomers. So isomerism is like a phenomenon, but the compound that exhibits the isomerism are called isomers. So the compound that exhibits the isomerism, are called isomers. They are called isomers. So isomers, they are the compound, while isomerism is a phenomenon. So therefore, the compounds that exhibit isomerism are known as isomers. So the word isomer is derived from the Greek word isos and meros. So the isos meros means equal parts, and the term was coined by the Swedish chemist called Jacob Berzelius in the year 1830. So it means that the first scientist that was able to coin the word isomerism is Jacob Berzelius in the year 1830. Isomers are the compound that exhibit isomerism, while isomerism is a phenomenon that shows how elements have the same molecular formula but different structural formula. Okay, so after this, the next thing is the different types of isomerism. So we have, of course, we can have 2D structure of a compound, and we can also have 3D structure of the compound. So when we have 2D structure of the compound, 2D structure of the compound. So in terms of the 2D structure of the compound, we have structural isomerism. So under the structural isomerism, we have what we call chain isomerism, positional isomerism, functional isomerism, metamerism, tautomerism, and ring chain. So as I said, under isomerism is divided into two. We have structural isomerism, stereoisomerism. So stereoisomerism is divided into two, and it always apply in 3D structure. It always apply in 3D compound or in the 3D structure of a compound. And this stereoisomerism, we have geometric isomerism and we have optical isomerism. So we are now going to look at each of these types of isomerism. So starting with the structural isomerism. What is structural isomerism? So in the case of structural isomerism are the types of structural isomerism is also known as constitutional isomerism. So that is the older name for structural isomerism. So in this case, the functional group and the atoms and the molecules of this isomer are linked in different ways. So it means that the functional groups of the compound, as well as the atoms in the molecules, as well as the atoms in the molecules of these isomers are linked. They are linked in different ways. Although the number of carbon, the number of hydrogen, the number of the number of atoms, as well as the functional groups are all the same. The number of atoms and the number of carbon, hydrogen, they are all the same, but the way they linked with each other are differ. So that's structural isomerism. It means that they have the same number of atoms, but the atoms linked in different ways. So these types of isomerism is called structural isomerism. So different structural isomers are assigned different IFAC names since they may or might not contain the same functional group. So after these isomers, they are exist, or when these isomers exists, because the arrangement of atoms or the linkage of the atoms may be differ, so their functional group may be differ also at the same time. So as a result of that, the IFAC names of those compounds may be differ. So you don't expect the compounds that have the same molecular formula but different arrangement to have the same IFAC name. When we said IFAC name, it means International Union of Pure and Applied Chemistry. So IFAC name is like a way of naming organic compound or inorganic compound. So if compound have different structural arrangements, so their IFAC name might not be the same. So the different types of structural isomers will be discussed in this subsection. It will be discussed in this subsection. So in a simple way, when we say structural isomerism, it means that they are the compounds that if you see them, they have the same number of atoms, but the atoms are linked in different ways. They have different arrangement. So as a result of that different arrangement, they may not have or they may not contain the same functional group, and also their IFAC name might not be the same. It means that whenever there is a different linkage of the atoms, there are different linkage of the atoms, even though they have the same number of carbon, the same number of hydrogen, same number of all other elements that are in the compound, but as a result of that different arrangement, their functional group may be differ as well as the IFAC name. So here we are going to look at different types of this isomerism in detail. So now we are starting with chain isomerism. So in the case of chain isomerism, it's also known as it has another name called skeletal isomerism. It also has another name called skeletal isomerism. So it's also known as skeletal isomerism, and the component of this isomer display differently branch structure. They have different branch structure. Like for example, let's look at the compound here. You can clearly see that here this is one, 2, 3, 4, 5. So we have 5 carbon and it is all linear. So that is why, because it is linear, and that is why it's called N-butane. That is normal butane. And at the same time, if you go down, we see that we have 2-methyl butane because we have one methyl group attached as a branch. So you see 1, 2, 3, 4, 5. So the same number of carbon and also the same number of hydrogen atoms, but there is arrangement. There is an arrangement. Commonly, chain isomers differ in branching of carbon. So you see here there is no branch in this compound, and here there is a branch at position 2, and the branch compound is methyl and is at position 2. So that is why it's called 2-methyl butane. So in a chain isomerism, is just trying to talk about the different chain or the different branching of carbon in a compound. So you see here we have 2-methyl butane, and at the same time when we come down, we see that we still have another methyl as a branch, as also branch. So that is why 2,2-methyl dimethyl propane, because at carbon 2 there are 2 different methyl. There are 2 different methyl. So these 2 different methyl, that is why it's called 2,2-dimethyl propane. So you see clearly here the number of the name is not the same. So that is structural isomerism. They have the same number of carbon, the same number of hydrogen. So it means that the number of atoms are the same, but they are linked in different ways. They are arranged in different ways, and that is isomerism. So in the chain isomerism, it's all about the branching of carbon. So you see here there is a branching of carbon in the first compound in N-pentane, no branching. In compound 2, there is branching. There is one branching, and in the last compound, which is 2,2-dimethyl propane, there are 2 branching. So in a chain isomerism is the types of isomerism that observe the branching of carbon in an organic compound. So branch, how compound form branch at different position. So the next thing that we are going to look at is positional isomerism. So in the case of positional isomerism, in the positional isomerism of a functional group, all substituted atoms are different in position. So in this case, the functional group or substituent of an atoms are different in position. Like for example, now let's look at the compound here. In this compound, we can clearly see that we have chlorine at carbon 1. So it means, and chlorine here is a substituent. So that is why it's called 1-chloropropane. So the position of chlorine in the second compound here is at position 2. So that is why it's called 2-chloropropane. So positional isomerism is a type of isomerism that trying to talk about the position of the functional group or substituent, but in different ways or in different position. So when you have a functional group or the types of isomerism that talk about the functional group of substituent that are at different position is what you call positional isomerism. So you see clearly here chlorine in compound 1, even though the number of carbon are the same, the number of hydrogen are the same, like is CH3, H7, and this is Cl chlorine. So they are the same in both compound 1 here and the compound 2, but they are different in arrangement. That is, they are different in position. The substituent, which is chlorine, or the functional group are deeper in position. So this type of isomerism is called positional isomerism. It is called positional isomerism. So that is for the positional isomerism. So it's just about how functional group or substituent are differ in position. So typically, this isomerism involves the attachment of functional group to different carbon atoms in the same carbon chain. So in the same carbon chain, you can have the different or that you can have attachment of functional group or substituent at different carbon atoms, but within the same carbon chain. Within the same carbon chain. So that is in the case of positional isomerism, it's the same compound, but the functional group or the substituents are changed in position. Maybe it is the functional group or the substituent is at carbon 1 in the first compound, and in the second compound it may be at carbon 3 or at carbon 4. So these types of positioning of functional group or substituent is called positional isomerism. It's called positional isomerism. So the next thing is functional group isomerism. So what is functional group isomerism? So in the case of functional group isomerism, as the name suggests, it refers to the compound that have the same chemical formula but different functional groups attached to them. So an example of this functional group isomerism is propanol and propanone. So propanol and propanone, if you can see this compound clearly, you can see that the number of carbon are 3. 1 oxygen, so you have 3 carbon, you have 1 oxygen, and you have 1, 2, 3, 4, 5, 6. 6 hydrogen, and there are 6 hydrogen. Also 1, 2, 3, here is 3. 1, 2, 3, 4, 5, 6. And there is 1 oxygen. So you see the number of carbon and the hydrogen are all the same in the compound, in the 2 compound, but this is a functional group and this is also another functional group. So they are not the same functional group. So this is alkanal. This is alkanal functional group. And of course, this is alkanone functional group. So these types of isomerism in which the compound have the same chemical formula but different functional group is called functional isomerism. Compound that have the same molecular formula but different functional group is called functional isomerism. And of course, if you said functional group is a compound or group of compounds, or is an atoms or group of atoms that determine the chemical properties of the compound. So it means that since this compound, they have different functional group, it means that they have different chemical properties, but they are as they have different structure, they have different functional group, but the number of atoms are the same. So since the structure are different, the functional group are different, therefore their chemical properties will not be the same. So this type of isomerism is known as functional group isomerism. So the next thing is metamerism. So what is metamerism? Metamerism is also another type of isomerism, arises due to the presence of different alkyl chain on each side of the functional group. Different alkyl chain. Like for example, here is an alkyl chain. Here is an alkyl chain, and here is also another alkyl chain. So, but if you look at it, the alkyl chain here are differ from one another. The alkyl chain here is methyl, while the alkyl chain here is ethyl. So this type of isomerism arises due to the presence of different alkyl chain on each side of the functional group, and of course this is the functional group, which is ether. So, and of course here, because it is ethyl, that's why it's called ethoxyethane, and here is methyl, so that is why it is 1-methoxypropane. So this type of isomerism in which alkyl group chain are on different side of the functional group is called metamerism, and it is really and it is a rare type of isomerism, and it is generally limited to molecules that contain a divalent atom. So it's only limited to elements that have divalent atom like sulfur and oxygen, because if you look at the sulfur and oxygen, they are all deficient in 2 electrons, so that is why they are called divalent, and they are surrounded by alkyl groups. So examples of this compound is represented as ethoxyethane and methoxyethane. So this type of isomerism due to the different alkyl groups, alkyl chain on different sides of the functional group is called metamerism. So the next types of isomerism is tautomerism. Tautomerism is just a hydrogen shift. That is a tautomer of a compound refers to the isomer of the compound which only differ in position of protons and electrons. Like for example, the protons here can be hydrogen. Like for example, let's look at the compound here. You see, here is just oxygen, and here there is a hydrogen. So if you look at between this compound and this compound, there is a shift of this hydrogen to this position. So you see, one hydrogen atom is shifted to this position. That is why here we have OH, and here is just oxygen. So hydrogen is shifted from this carbon to this oxygen. So that is why, and of course, look at it here. This is a keto form. And of course, this one is enol. This is enol, and this is keto, because the difference is the double one is between carbon to oxygen, and that is why it's keto, and the double one is between carbon to carbon, and that is why it's called enol form. So tautomerism is just a change of position of protons or electrons in a compound. So typically the tautomers of a compound exist together in equilibrium and easily interchanged. So they usually exist in equilibrium, and they can be interchanged depending on the situation, but they are very stable, and they can exist at equilibrium. So it occurs via an intermolecular proton transfer. Of course, proton is hydrogen, so proton transfer, protons here is transfer to this, and that is why it's now changed to enol from keto. So an important example of this phenomenon is keto-enol tautomerism. So that is for the tautomerism. That is for tautomerism. So the next types of isomer that we are going to look at is ring chain isomerism. So in ring chain isomerism, one of the isomers has an open chain structure, whereas the other has a ring structure. So they are generally contain a different number of pi bonds. The different number of pi bonds. Then a great example of this type of isomerism can be observed in C3H6. So propane and cyclopropane are the resultant isomers as illustrated below. So now, what we are saying in this case of ring chain isomerism, so this we let's just not look at this structure that here dicyclobutane and methyl cyclopropane. So in what we want to what is the most important thing that we should need to understand is that these types of isomerism is usually found when there is a compound that contains different number of pi bonds. Like for example, in the case of propene and cyclopropane. So in propene, this is propene. It has one double bond. So it means that if there is one double bond, it means that there is one pi bond. And of course, cyclopropane, this is cyclopropane. So in cyclopropane, there is no any pi bond. So these types of isomerism is called a ring chain isomerism. So one of the isomers has an open chain. So this one has an open chain, that is propene, and the other one has a ring structure, and that is this. So if we are now going to look at the cyclopropane and propene, we can see that clearly in propene the number of carbon are 3, and of course there is one double bond, and here there is one hydrogen, and here is 3. So you can see that 1 2 3 1 2 3 4 5 6. So there is 3 carbon and 6 hydrogen. And then let's now go back to cyclopropane. And so in cyclopropane, we have one carbon here, we have one carbon here, we have one carbon here, and then bonded here, then 2 hydrogen here, 2 hydrogen here, then 2 hydrogen. So we have 1 2 3, we have 3 carbon, and we have this one is 2, and this one is also 2. So there are 6 hydrogen. So you see they have the same number of carbon atoms, but and hydrogen atoms, but the structure are differ. So this one have an open chain and this one have a ring chain. So this types of isomerism is called ring chain isomerism. And in ring chain isomerism, one must have linear chain and the other one must have ring chain in the case of these types of isomerism. So the next types of isomerism that we are going to look at, which that is the one that have a 3-dimensional structure, is stereoisomerism. So what is stereoisomerism? So in the case of stereoisomerism, so this type of stereoisomerism arises in a compound having the same chemical formula but different orientation of an atoms belonging to molecule in 3-dimensional species. So in these types of isomerism, we are trying to look at how compounds that have the same formula, but different orientation of the atoms. They have the same chemical formula but different orientation of the atoms. So the compound that exhibits stereoisomerism are referred to stereoisomers. So this phenomenon can be categorized into 2 subtypes. So both these subtypes are briefly described here. So we are starting with the geometric isomerism. So in the case of geometric isomerism, is also known as cis and trans isomerism. So the position of the groups around the double bond are different. So it means that in positional isomerism, the double bond must come. So that is why here you have carbon. That is why here we have carbon. Here we have carbon. That is why here we have carbon we have carbon to carbon double bond, but there must be a position of groups around the double bond. So the position of groups here, you can see that you have methyl here and you have methyl. So the methyl and methyl here are all at the same direction. So since they are all in the same direction. So if similar group lies on the same side of the plane, the compound is referred to as cis isomerism. Is referred to as cis isomerism. So this one is actually, this structure that is demonstrated here is wrong. So it means that if you have a compound where you have compound like this, where they have a double bond between carbon to carbon, there's a double bond, like in this case. So if you have CH3 here, you have CH3. So if you can clearly see that, and of course here we have hydrogen and hydrogen. So if you can see clearly here, at this point we have the same metal, so they're on the same direction. This CH3 and CH3, they are all on the same direction. So these types of geometric isomerism is called cis-2-butene. Cis-2-butene. So when you say cis-2-butene, it means that the functional group is at position 2, and it is cis because all the CH3 and CH3 are on the same plane. They are all on the same plane. And conversely, if the group lie on opposite side of the plane, of the molecule, it is referred to as a cis isomerism. Sorry, it's referred to as a trans isomerism. So it means that if you have a situation where you have something like this, you have carbon to carbon double bond, and you have CH3 here, and you have another CH3 here, and you have free hydrogen. So you see, they are transverse. That is why it is called trans isomerism. So if you are going to name this, it is going to be trans-2-butene. So it means that there is a restricted bond, which is a double bond, and there are groups that attach to it. So if the groups are on the same plane, if they are on the same side of the plane, they are called cis isomerism. And if they lie on the opposite side of the plane, they are called trans isomerism, from the word transverse. So the next types of structural isomerism that you are going to look at is optical isomerism. So in the optical isomerism is a case where the isomers display identical characteristics in terms of molecular weight as well as the chemical and physical properties. So they usually have physical properties and chemical properties, but the only difference, they are mirror to each other. Like for example, now here, look at our hydrogen here. So you can see that clearly the hydrogen we have here, we have hydrogen here, we also have hydrogen here. So this compound is a mirror image to this compound. So that is why in stereoisomerism, the compound have the same, or they have identical characteristics in terms of molecular weight as well as a chemical and physical properties, but they are mirror image to one another, and that is why this one is positive and this one is negative. It's lactic acid. So in optical isomerism, that is why we have L and D isomer. That is dextrorotatory and laboratory. So they are called optically active compound. They are optically active compound, and is always applied to a compound that have chiral carbon. This type of isomerism is applied to compounds that are called that have chiral compound. So when we say chiral carbon, it means that are the carbon that have 4 different groups attached to it. So whenever you have a carbon that have 4 different groups attached to it, so that carbon is called chiral carbon, or in some textbooks you will see it called stereogenic carbon, or in some textbooks they call it what you call asymmetric carbon, asymmetric carbon. So of course, now if you can see this this is a chiral carbon, because this group here is CH3 and this is hydrogen, this is OH and this is CH3. So you see that clearly the number of groups that are attached to this carbon are 4, and they are all different. They are not the same. So any compound that have these types of this type of carbon, it's said to undergo optical isomerism. And of course, we have a way of calculating stereoisomers. That is the number of isomers that the compound can produce. So to calculate the number of stereoisomers, then it's 2 power n, and this n stand for the number of chiral carbon. Like for example, in this compound, the number of chiral carbon is 1, so we have only 1 chiral carbon. So we have 2 power 1, so 2 power 1 is 2. So that is why it means that this compound can undergo only, or can have only 2 optically isomer compounds. So this is the first one and this is the second one, so that is why there are 2. So ladies and gentlemen, we are going to stop here. And if this is the first time you are coming to my YouTube channel, please subscribe. If this is the first time you are coming to my YouTube channel, please subscribe. Thank you. See you in the next video.